Today's date's the 27th. Alright, looking at this one here, how many litres of oil can be stored in this drum? Okay, and so some of the process you go through for this one is to calculate the area of the base and times it by the height. Yeah, alright. So our excuse me, our base is there. Okay, and so what's the, so again we're saying area of base times by the height. Okay, so this will give us the volume of that tank. Does that make sense to you, Will? Yep. So Will, what's the area of the base? What's the formula we would use?
Pi times radius squared.
Pi times radius squared. Excellent, because that's a circle, and that's the area circle formula. Times by our height. So pi r squared, what's our radius there, please, Tani?
28.5.
28.5. So we're pi times 28.5 squared times by our height, which is 85?
Yep.
Yep. 85. What I tend to do, especially with your calculator, sometimes you can press the buttons in this order: pi times 28.5 squared times 85. Some calculators will do the times pi by 28.5, and then you're squaring that number rather than squaring the 28.5. Does that make sense, Will? So how I tend to do these, just to be on the safe side, because all calculators are different, I'd say square 28.5 first, multiply it by pi, and then multiply it by 85. Okay? So if you were to do that, you would get 28.5 squared, which is 812, times by pi, gives you 2,551 approximately, times by 85, which gives you 216,899.48, and I'd probably leave it at 48 cubic centimetres. Cubic centimetres. All right. When you've got that, tell me, I'll continue. So what does 216,899.48 cubic centimetres mean? It means that you can fit in to this drum 216,899, cubes of liquid a centimetre by a centimetre. Yeah? 216,899, nearly 800, nearly not 216,900 of them inside this drum. Okay, because it's the amount of space that something's taking up. We know that. All right. Now, they say how many, and the crucial word here is how many litres. Now, we've given our answer in cubic centimetres. A problem. Unless we're prepared to go back and say 1 kilolitre equals 1 cubic metre. Well, we haven't got it in cubic metres. All right, so that's a bit of a problem. But if we look back through our book, we start to get some information that's pretty consistent. So this is, for example, a cubic centimetre. Yeah, we've got cubic centimetres. 1,000 of them equals 1 litre. Yeah? So with this, what it would be mindful to do is say, if you had 1,000 of these, you'd have 1 litre of oil. Yeah? If you had 1,000 cubic centimetres, you'd have 1 litre of oil. If you had 2,000 cubic centimetres, you'd have 2 litres of water. Okay? What shall we do with 216,899? To find it. Yep, which will give you what? No, we'll give you what? What will the answer give you, rather than what's the actual answer? What measurement, or what metric unit will it give you?
Oh, litres.
It'll give you litres, won't it? And if we scroll back to our question, that's what our question's asking. How many litres? There we are. So if we then divide that number by 1,000, and the reason, because 1,000 cubic centimetres equals 1 litre of liquid. Okay? Divide it by 1,000, we're moving that 3 places. It gives us approximately 217 litres of oil. Could be stored in that drum. Conversion. How's that?
Alright, but I don't know what I'm doing wrong, because I'm doing exactly what you've done on the board, but I'm not getting the same numbers as you.
Yep, okay, so I'll come and work with you individually just to see how you're plugging them in. You understand that process? Teddy and Will, you understand that process? Nothing new there, is it? Okay, I just, for blue and green, if you can just maintain your focus here, please. I just want to go through what is relatively simple, but it's a really easy mistake to be made come test. And this is around converting, okay? Converting your volume units, cubic millimetres to centimetres, cubic centimetres to cubic metres, etc. Okay? So please pay attention. It's only going to go for a couple of seconds. When we're going 23 cubic centimetres to millimetres, you'll be given this chart. 23 cubic centimetres to millimetres. So we're going along this path. The bit that you may underestimate is this cubed. All right, can you grab your calculators out, please? All right. And I know this isn't rocket science for some of you, but for others of you, they're really simple errors to make, and they really will hurt you in a test. So you're typing in 23 times 10, and then I reckon you've got a button on your calculator which looks something like that. It might be y's to the power of 3, or it might be x's to the power of 3. Has everybody got at least one of those buttons? So your screen will look like this, folks. Your screen will look as something like 23 times that. Okay? Once you press equals, it spits out the right answer really easily. But too often in a test, or too often we can come to these conversion charts, and hey, we didn't do it awesome in the test just gone on area conversion or normal conversion, so don't overlook this as being, you know, so easy peasy, I don't need to concentrate. Too easy it's to overlook this to the power of 3, because what you're saying here is what you're giving your calculator to do is 23 times 10 times 10 times 10, yeah? 3 times. 1, 2, 3. All right? So please don't underestimate the need to be able to do these successfully. If you've got them all wrong, or if you've got any of these wrong, blue and green, I want you to go back over them, because these are sort of like the homework sheets. They're really easy to pick up marks on. I'm going to give you a chart. You've just got to be able to use that chart. Okay? They're easy to pick marks up on in a test or anything else. You're going to need it for your volume, for your directed investigation. So please make sure you can do it. Okay? Everyone understand? Yeah. Thanks. When we were looking further up from here, we were looking at prisms. We're looking at volume here, of course. And remember yesterday I spoke about when you look at these, imagine that they're a piece of cheese, and if you slice through, a prism has the same face no matter how many times you slice it. Yeah, does that make sense? We recall that sort of conversation. All right. When they're prisms, it's area, this is for volume, it's area of base times by your height, and that's what all of you would have been working with and are quite familiar with. All right. But, you know, because it's volume, whatever the measurement is, it's a cubic measurement, all right? But not everything are these, not everything are these prisms where they're the same shape at the top as they are the bottom, all right? We know that they're called pyramids, okay? Pyramids or cones. That's where they have a flat base but they come to a point at the top called an apex. Okay? This comes to a point, there it is. This comes to a point, there it is. And you can see the cone. The cone comes to a point at an apex above its base. Alright? You can see that that happens. Now, when you are dealing with those, you are dealing with this formula. Area of base times your height remains the constant. Yeah? That's still what we spoke about with the prisms. But with the pyramids, you just get a third of that. Alright? So the determining factor when asked to calculate the volume of a shape, you've got to say to yourself, does it come to a point, and if it does, it's 1/3 the area of base times by your height. Alright? If it doesn't, if it's looking like this, sorry about my artistic talents, then the volume of that is just area of base times by height. Okay? Or if it's a rectangular prism, again, we've still got the same shape on the end as we have on this end. So that's a prism, okay? And we're using the area of the base times by the height. When they come to a point at an apex, okay, it's 1/3 the area of the base. It's just the third that changes, but be aware of that. Okay, is everyone okay with that? What you'll generally be using in your M&M's project generally will be prisms, not pyramids, but you do have to do one pyramid. So I'll be able to see your understanding and learning from that. Okay? Any questions with that? I just wanted to really identify that and the conversion charts today. Can you grab your M&M's project out, please? Attention this way, please. 3, 2, 1. M&M's today. What are some things we want to knock on the head in terms of our DI? You're able to open those M&M's packets. They are now yours. We want to work out the volume of one M&M. Yes, good. Anything else?
How many M&Ms are in the packet?
How many M&Ms are in each packet? How many M&Ms per packet? Now, what we want to do there is a class average. Okay? So, I need you to open them all. I need you to wash your hands probably beforehand. Make sure that you are counting up how many and coming up and recording them. We'll work out the average so that you can work out what, Maddie?
So we can work out how many are in there.
Yeah, which will help us with what, sorry?
Like recording how much it takes up.
Yes, that'll then give us our total volume required for our shape. Yeah? Alright. So there's about 3 handy tasks to do today. I reckon we've got a good structure of time now. We've got an hour. Let's bang away at that as quickly as we can. Don't eat them before you count them. And don't eat them before you need them for other things.
Oh, well, yeah. I've eaten 5. You're just gonna have to add 5 to your total.
Oh, it's losing serving size.
Oh, yes. Oh, God.
Well, you know, if you want that's something that actually has good it's three things. And not like I've got to know, like the each time I like yeah, and then that's it. And then you can't sort it out.
Depends on how many you're packing.
No, then like package the chips,
Hey guys.
Like, why would you do a cup and then like
I'm not eating mine.
So I'll count them now?
Remember your number.